In the part 1 video, we just finished up this example here. Before I move on to the next one, which is where I give you the equation and we have to graph it from scratch, I want to review the main ideas that you should have picked up on while we were completing the problems on the front page and that first problem on this back page here. So today we are looking at standard form for a quadratic function. Looking at the equation, we should be able to identify a, b, and c. A is the term or the number in front of the x squared, b is the number in front of the x term, and then c is the constant or the number on the outside. Whenever we take a look at a, okay, so a tells us specific things about the graph. If a is positive, so greater than 0 just means a is positive, it's going to open up, looking something like this. If it opens up, that means we're going to have a minimum for the vertex. If a is negative, then the graph is going to open down. And if it opens down, we're going to have a maximum for the vertex. That's not the only thing that a can tell us. It also tells us if we're going to have a stretch or compression. If it is between, and there's a typo here, if it is between 0 and 1, it's going to appear wider or be a compression. If the absolute value of a is strictly greater than 1, then it's going to appear narrower, or it'll be a vertical stretch. Now remember, I didn't talk about it so much in this video, but we have in other videos. When you have a stretch or compression, it affects how it moves. So if I had started at a vertex and there's a stretch of 2, I would move right 1, up 2. Or right 1, down 2. Depending on, whether or not it opened up or down. Or if I had a vertical compression of 1/4, I would move right 1 and up 1/4, or right 1 and down 1/4. It also can work moving to the left. A and B together can give us the x coordinate of the vertex. In order to find the y value, we'd have to take our new x value and plug it in to the original function. So that's what this notation means. We're taking our x value, negative b over 2a, and then we're plugging it back into the equation. Coincidentally, the axis of symmetry, this is what I call the AOS, the axis of symmetry, which is that vertical line, will always pass through x equals, I called it h, but in this case h is the negative b over 2a. Remember, the axis of symmetry is what cuts our parabola in half. So the points on the right-hand side and left-hand side are equidistant, from the axis of symmetry here. Last thing, that c value represents the y-intercept. Okay, so the c value is the y-intercept. And when we're graphing, we're going to use this as a symmetric point. We'll see what that looks like here in a moment. Okay. Now we're actually going to graph given an equation. The first thing that you want to do is identify a, b, and c. A is -2, b is 6, and c is -2. I'm going to use the key ideas from the table that's below to help me fill in what the key characteristics should my graph have. Okay, A is -2. Remember, A tells us 2 things. In this case, A is negative, And that means that my parabola is going to open down, or I'm going to have a maximum for my vertex. Also, the actual value is 2. Well, 2 is greater than 1, so A was greater than 1, and that means that I'm going to have a stretch. Next, the C value, I want to remind you, is my y-intercept. So I actually can go ahead and plot that point. Along the y-axis, I want to find where -2 is. And that would be right here. That's not all the information that I can figure out. I can use x equals -b over 2a. Remember, this gives us our axis of symmetry, or the x-coordinate of the vertex. Plugging in my values, I have -b was 6, and then that's over 2 times a, which was -2. So I have a -6 over a -4. That simplifies. Scooch it over so you can see it a little bit. That simplifies to a positive 3/2. Like I said, that gives us the x value of the vertex, but I also need to know the y value. To get the y value, I need to plug my x value that I found into the original equation. So I have y equals -2 times 3/2 being squared plus 6 times 3/2 minus 2. If you would like, you could plug this into your calculator, but there has been problems in the past with students plugging it incorrectly. So make sure that when you are squaring your fraction, you use parentheses. So parenthesis 3 divided by 2, close your parentheses, then square it. I'm just going to do it from scratch and go over a few properties you should know from Algebra 1. I'm going to start here. I'm going to distribute the power to my 3/2. So this becomes -2 times 9/4, because 3 squared is 9, 2 squared is 4. Plus, now here, when we multiply fractions, remember you go across the top, across the bottom. So really, it's 6 times 3 over 1 times 2. Or, I know that 6 over 2 becomes a 3 over 1. So really, it's plus 9 here. Okay, minus 2. Likewise, what I just did here, simplifying, 2 over 4 becomes 1/2. So that's -9/2 plus 9 minus 2. When you add or subtract fractions, you need to have a common denominator. So -9/2 plus, this is technically 9 over 1. I want a common denominator of 2, so I'm going to multiply by 2 over 2, giving me 18/2. Do the same thing, multiply by 2 over 2, which is our fancy form of 1. I end up with 4/2. Meaning that the y value is 5/2. Again, you could have plugged that into your calculator. I just wanted to review a couple of concepts that we're going to be coming back to and using a lot later on. Okay, but for now, let's go back to our graph, and we need to plot a coordinate for, or plot a point for my vertex, which is at positive 3/2, so that's 1 and 1/2. That would be right here. And then we're going to go up 5 halves. That's equivalent to 2 and a half. So that would be right here. Right 1 1/2, up 2 1/2. That's not the only thing that I need to do. I'm also going to put my axis of symmetry. Once again, the axis of symmetry will always pass through our vertex. So this axis of symmetry is located at x equals 3 halves. To draw any parabola, you need at least 3 points. I only have 2 here. So this is where, if you look at the table where it says y-intercept, we're going to use the y-intercept to find a symmetric point. The axis of symmetry helps us because we know that our points are equidistant to this line. So this point here, my y-intercept of -2, is 1 1/2 units to the left, meaning I can plot a point 1 1/2 units to the right. I now have 3 points, which means I can connect them and create a parabola. I know it doesn't ask for this, but it's a great opportunity for learning here. And we struggled with this a little bit. I want to talk about domain and range. Remember, domain for a parabola is always all real numbers, or you can write it using interval notation. Range must always be down to up. This function is going down forever. So I need to list a -infinity first with a parenthesis because I cannot reach that. It is not included in my graph. And then the highest point is here. I need to use the y value of my vertex because range is y value. So I'm going to use the 5 halves, and I must use a bracket because it is included on the graph. All right, last one. From 2000 to 2006, the consumption of poultry per capita is modeled by this equation here, where t equals 0 corresponds to the year 2000. During what year did the consumption of poultry per capita at its maximum? Okay, the key word here is maximum. Maximum means we're going to have to find the vertex. And when something's written in standard form, we find the vertex by using that x equals -b over 2a. Okay? B is going to be 2.615 all over 2 times a, which is here, -0.2125. You can go ahead and plug that into your calculator, but I would end up with approximately 6.153. If you were to plug all of this in at once, you'd have to put -2.615 divided by parentheses and then plug this in. Okay, if you don't put the parentheses and you're plugging it in all at once, what your calculator will end up doing is this divided by 2 and then multiplying. What might be better is just to do -2.615. Go ahead and find out what 2 times -0.2125 is, which is actually -0.25, and then divide. That makes it so you're not trying to do too much at once. Okay. Anyways, X is actually going to represent our years. So if my answer is approximately 6.153, where T was representing the year 2000 when it was 0, that means 2000 plus 6 in the year 2006 is when it's reached its maximum. So that's my answer, the year 2006.